Hi, my name is Marco and I'm thankful you took time to review my application. Here is a quick engineering portfolio of the things I've done in the last 10 years. In 6th grade, the flight just astonished me, and I spent countless hours trying to make many contraptions fly. Around 7th grade, I started experimenting with electrical circuits. Fortunately, I didn't manage to save a video of a calculator I made using only transistors that could calculate up to 10. Later, I managed to get my hands on Arduino and cheap RC modules, which I used for many RC projects. To make my projects more interesting, in high school I started using Raspberry Pi and machine learning. The limited experience I had encouraged me to found robotics team, and we eventually ended up representing Serbia on European Championship in Paris. I worked on the mechanics of the main mechanism, as well as the electronics of the main PCB board. I was developing regulation for both current and voltage, and circuits for powering the actuators and the reading from the sensors. Here are a couple of video clips showcasing the testing of the main mechanism and control of the robot in the field, as well as a video clip from National Championship where we competed as the only high school team. To understand the math behind the neural networks and machine learning, I coded up the multi-layer neural net from scratch with Adam Optimizer and trained it on the brain cancer dataset, achieving over 95% accuracy on the test set. For me, the most interesting physical simulations I made were the simulation of propagation of waves around obstacles, mostly for nice visualizations, the simulation of black hole and the space-time around it based on the math from Susskind lectures depicted in the following animations I plan to upload as a YouTube video. Very fun but quite inefficient project is one where I applied reinforcement learning and Markov decision processes to learn to stabilize famous inverse pendulum in a simulation. I'm currently working on an autonomous bike project intended to control a bike only based on 2D camera input. To achieve a tenfold increase in frame rate and enable real-time performance, I run inference and scene reconstruction on my laptop, carried in a backpack, and communicating wirelessly with a Raspberry Pi mounted in the bike's enclosure. The Raspberry Pi interfaces with Arduino that executes PID algorithms and low-level control commands. I designed and built the entire mechanical system, including the power transmission for forward motion and the steering reduction mechanism. For safety, an emergency cord electrically cuts off power to all actuators. I was later invited to the Novi Sad Science Fair to showcase the software I developed. I wanted to thank you all on your attention, and I hope we are going to see each other in the next semester.